Okay, so in this video, we're going to be talking about solving two-step equations. Now, before you try this video and the problems in this video, make sure you check out my other video on solving one-step equations because you have to get the fundamentals down before you can move on to two-step equations. And I'll go ahead and put the link to that video below in the description box so that you can have access to it. And so again, make sure you check out that video before you try to do this one. So let's do a basic review here. When we're solving equations, we know that we have to do the inverse operation in order to isolate the variable. So for example, on number 1, I'm trying to isolate x, right? That is my goal. Now, in order to do that, I have to do inverse operations, and I wrote them down here, and you can probably memorize them pretty easily. We know that the opposite of addition is going to be subtraction. We know that the opposite of multiplication is going to be division, and vice versa, okay? So in order to do this problem, right, you can think about doing PEMDAS in reverse. If you're confused about what to do first, write out PEMDAS, okay? And this is something you can do in the beginning. Over time, you won't have to do it as you get more efficient at doing these problems. But you can go ahead and write out PEMDAS. And again, we're just gonna box in addition and subtraction and multiplication and division because they have the same order of operation. And in order to solve this equation, you're just gonna do it in reverse. So if you're confused about what step to do here on this equation, do PEMDAS in reverse. So if I do PEMDAS in reverse, I have addition and subtraction. So that means in order to isolate x, I have to take care of either addition or subtraction first, going left to right. So going left to right, I see that, oh, look, I have addition right here. I'm gonna have to take care of that, okay? So that's gonna be our first move. So that's something you can use as you go through these problems. Again, over time, you're not going to have to, but keep that in the back of your mind while you're doing these problems. It could make it easier. So let's go ahead and do that. I have a positive 7 here, meaning I'm going to minus 7 on both sides, right? That's my first move that I need to do, okay? Remember, wherever you do the operation first, that always cancels out. That will always happen. I'm going to bring down 5x. And then I have equal to 22 minus 7. That's going to give me 15, okay? So I get 15 here. Now, all I have to do now is get rid of this 5. Now it's a one-step equation. So what is the operation right here? The operation right here is multiplication. So in order to get rid of that, I have to do the inverse operation, which is going to be division, right? So I'm going to divide both sides by 5. This will cancel here because that's where we did it first. And I get x is equal to 15 divided by 5. We get 3. Okay, this is it right here. Now again, you can always check it to make sure you did it correct, and we can do that using mental math. If I take this 3 and plug it back into x, that means I have to do 5 times 3, which will give me 15, okay? And then plus 7. Will that be equal to 22? And yes, it will be equal to 22. Again, you can do a quick mental check when doing these problems to make sure that you did it correct. So if you plug it back in and it doesn't equal 22, you know that you did something wrong up here and you're gonna have to go back and try to resolve the equation, okay? Let's try number 2. So again, if you're confused about what step to do here first, use PEMDAS in reverse. Now I'm gonna rewrite this problem. It's x divided by 3, okay, plus 2 equal to 6. So again, what do we do first here? Well, again, if you're confused, look at PEMDAS, go in reverse. That means I have to do either addition or subtraction first, going left to right. So going left to right, see that I have addition. That's the first move I need to take care of. So I am going to do the opposite, which is minus 2, right? And we're doing that on both sides as we go, okay? And we're gonna cancel out right here, and I get x over 3 equal to 6 minus 2, that will give me 4. So now we have a one-step equation. How do I solve it? Well, look, I'm trying to isolate x. I have division. What is the opposite of division? Well, the opposite of division is going to be multiplication. So I'm going to multiply both sides by what I'm trying to get rid of, and that is 3, okay? This will cancel right here. It always does, right? Wherever you do it first, it always cancels out. And I'm left with x equals 4 times 3. Well, that's going to be 12. So x is equal to 12. Right, and you can do a quick mental check, plug it back in. 12 divided by 3 is 4, plus 2, yes, that is equal to 6. We did it correct. Okay, Let's try some more problems here. Okay, so here are some more problems. And again, what do we need to do first on number 3? Now this one's a little tricky because you have a set of parentheses here, right? And so again, think about PEMDAS in reverse. What do we need to do here? Well, this problem here, there's kind of a bunch of different moves you can make here to solve this problem. What you don't want to do is the following. You may look at this subtraction right here and think, oh, I'm just going to add 2, right, on both sides. But remember, PEMDAS in reverse. This x minus 2 is in parentheses, right? That's at the top of our order of operations when you're looking at PEMDAS, okay? So I don't want to add 2 here. Rather, I'm going to want to take this 2, which is being multiplied inside, and I'm going to want to divide, okay? I'm going to want to divide both sides by 2. Now, another way you could do it, you can take this 2 and distribute inside, right? You could do that if you want to. You're going to end up with 2x minus 4 equal to 12. That's definitely a way you can do it, right? So what I'm going to do here, I'm going to go back, and I'm just going to divide both sides by 2. Typically, when you do it this way, you have less steps and the problem's going to be much easier. So the 2's will cancel right here. I'm left with x minus 2 equal to 6. All right. So this method here that I'm showing you usually results in the path of least resistance. It's definitely a more efficient way to solve these problems. But again, you can distribute that 2 if you would like. You're going to get the same answer in the end. You just may have more steps. Okay. So from here, I see that I have subtraction. I'm going to add 2. On both sides, right? And so what do we end up with? Well, it cancels out right here. I get x is equal to 8. All right, 6 plus 2, I get 8. Let's go ahead and box that in. And we can do a quick check here. So 8 minus 2, I get 6. And then times 2, yes, I do get 12. Right, so that works out. Okay, so let's go to number 4. We got 4x all over 2 equal to 10. So again, remember the goal that you're trying to achieve here. You're trying to isolate x. So looking at what I need to do first here, I'm going to have to isolate this 4x. I need to get that all alone, right? So how do I do that? Well, I need to get rid of this 2 here. And this is division, right? We have division right here. So the opposite of division is going to be multiplication. So I'm going to multiply both sides by 2, right? So we're going to go ahead and do that. This will cancel here. It always does. I get 4x is equal to 10 times 2. It's 20. Okay, so now I have that 4x isolated. Now I see its multiplication, right? 4 times x. The opposite is division. I divide both sides by 4. And we're done with the problem now, right? Cancels out here. 20 divided by 4 will give you 5. So x is equal to 5. Again, do a quick mental check. Does it make sense? If I plug it in, right? Here's my x. I'm going to do 4 times 5. That is 20. Divided by 2, yes, that is 10, right? So that checks out. Okay, let's do one more problem, and it's going to be a bonus problem. So here's our next problem, and this is not a 2-step equation. It's actually going to be a multi-step equation. So what do we want to do first here? Well, remember the goal. You want to isolate x. So you could take this 5 and distribute inside. That's totally fine, okay? Another way you could do it, and again, this is going to be the path of least resistance. You could take this negative 3 and move it over by adding 3. And then you're going to have a similar setup to what you were just doing in the previous problems. But again, if you were to distribute the 5, that's fine. You're just going to have to combine like terms after that and then go from there. But I'm going to do this method here where I'm going to add 3. Okay. Add 3. This will cancel. And I'm going to bring down 5 and then x plus 2 equal to 12 plus 3 is 15, right? So now the setup is very similar to what we were just doing. And again, you could distribute the 5 here. That's totally fine. But for me, I find it much easier to divide by 5 since that is the operation there. It's multiplication. It's 5 times everything inside. So the inverse there would be division. I'm going to divide by 5 then to get rid of it. So the 5's will cancel here, and I get x plus 2 equal to 3, and we're almost done. So it's pretty simple from here. You can see that I have addition here, right? So I'm going to have to minus 2 on both sides. Okay, minus 2 on both sides. So what do we get there? This will cancel. I get x equals, what is 3 minus 2? We get 1. x is equal to 1. Okay? And let's do a quick mental check here. Does it make sense? If I plug it in, again, order of operations. So I'm going to do 1 plus 2, which is 3, times 5, that's going to give me 15, minus 3, that will give me 12, right? So that checks out. Okay, so that is solving two-step equations. If you found the video helpful and you gained something from it, make sure you give this video a thumbs up and make sure you subscribe for more math videos in the future, and I'll see you in the next one.